In this lesson, we are going to learn how to solve systems of linear equations. So on problem numbers 1 through 10, we're going to use the addition, otherwise known as the elimination method. And on problem numbers 11 through 20, we're going to use the substitution method. For anyone who might be watching this video who is not in my class, there is a lot more to these methods and to systems of linear equations that I will not be showing. This is a very, very basic review of systems of linear equations. So if you're looking for more in-depth, this will not be the video for you. Okay, so in systems of linear equations, your answer is always an ordered pair. And if you remember, an ordered pair is when you have your x value, your y value, and the comma in between. So an ordered pair has parentheses around it, your x value, your y value, and a comma in between them. When we're solving systems of linear equations, we are trying to find an x and a y value that works for both equations. So on problem numbers 1 through 10, we're going to use that addition elimination method. So that means we're going to be adding these two equations together, and we should expect something to eliminate because of the elimination method. So when we add these two equations together, negative 4x plus 4x, well, those give you 0, so they're gone. Then I have negative 3y plus negative 4y, which is negative 7y, and then 11 plus negative 4 will give us a positive 7. So now I have to get that y by itself, because I don't care what negative 7y is, I want to know what y is. So I'm going to divide both sides by a negative 7. The opposite of dividing by a negative 7 would be to, the opposite of multiplying by negative 7 would be to divide by negative 7. So that's going to give me y equals a positive 7 divided by a negative 7 is going to be a negative 1. So I know that my y value for my answer is a negative 1. Next, I'm going to plug in my negative 1 into either equation, because if we want an ordered pair that works for each equation, that means that whichever one I plug my y into, I should get the same x regardless. So I am going to choose the equation with, let's just say the smaller numbers. We'll not worry about that 11 right there. So I'm going to use the equation 4x minus 4y equals negative 4. And then I'm going to plug negative 1 in for y. So that gives me 4x minus 4. And instead of writing the y, I'm going to write a negative 1 equals negative 4. So now we have to solve. First thing we do is multiply negative 4 times negative 1, which gives me a positive 4, and then you subtract 4 from both sides to get 4x equals negative 8. Divide both sides by 4 to get x equals negative 2. Okay, so now let's move on to problem number 2. So this is still the same method, so I'm going to add these two equations together. 3x plus 2x is 5x. 2y plus negative 2y, those are going to cancel or eliminate. And then negative 12 plus 2 is a negative 10. And to get my x by itself, I'm going to divide both sides by 5. So I'm going to get x equals negative 2. So now that I've found my negative 2 for my x, now I need to find out what y is. I can plug it into either equation I'm going to choose the top equation this time. Remember, it does not matter which one you choose. So I'm going to use 3x plus 2y equals negative 12. I'm going to plug negative 2 in for my x because that's what x equals. So I've got 3 times negative 2 plus 2y equals negative 12. So 3 times negative 2 is negative 6. And then we would add 6 to both sides to get 2y equals a negative 6. Divide both sides by 2 to get y equals negative 3. Okay? So let's move on to problem number 3. We will add these two equations together. Negative 2x plus 2x are going to give you 0, so they eliminate. 4y plus negative y. If you have to write the negative 1 in front of that y, that's okay. So 4y plus negative 1y is 3y. And then negative 12 plus a positive 12 is 0. And then you would divide both sides by 3 to get y equals 0. So if you have a whole that's divided into 3 pieces and you have none of those, then you're left with nothing. Now I'm going to plug my 0 into either equation. This time I'm going to choose the bottom equation. So I have 2x minus 1y equals 12. So 2x minus 1 times 0 equals 12. 2x negative 1 times 0 is 0. And then 2x plus 0 is just going to give us a 2x. Divide both sides by 2 to get x equals 6. Okay. And I apologize about not having these on my printed paper as I normally do. My printer is not wanting to work today. Okay, so I'm going to add these two equations together. Negative 5x plus x is a negative 4x. Y plus negative y, those are going to cancel. And then negative 18 plus 6 is negative 12. Now I'm going to divide both sides by a negative 4, and I want to get that x by itself, and that gives me x equals a positive 3. Now, to find out what y is, I can plug this x into either one of my equations. I'm going to choose the top one. So I'll plug in a 3 for x. So negative 5 times 3 is negative 15. Bring down your y and your negative 18. Then you add 15 to both sides to get y equals negative 3. Now make sure you're plugging these into your answer correctly, because your x should always go first and then your y should go second, and that's always. And I apologize for any ruckus in the background. My cats are going a little crazy this morning as well. So now I'm going to add these two equations together on number 5. So 5x plus 6x gives me 11x, and then 4y plus negative 4y, those are going to cancel, leaving me with negative 17 plus 6 is negative 11. Then I'm going to divide both sides by 11 to get that x by itself, which gives me x equals negative 1. And then to find out what my y is, I'm going to plug that x value into one of my other equations. Doesn't matter which. I'm going to choose the bottom one this time. So I'm going to plug in a negative 1 for my x. So that's negative 6 minus 4y equals a positive 6. Then I add 6 to both sides, which gives me negative 4y equals 12. Divide both sides by negative 4 to get y equals negative 3. Okay. Now for number 6, I'm going to add both of these equations together. 5x plus negative x. Remember, we can put a 1 there. To get 5x plus negative 1x is 4x. Negative 5y plus 5y, those are going to cancel. And then 0 plus 8 is 8. Now I divide both sides by 4 to get y equals 2. Now I'm going to plug that 2 into my y value on either equation. This time I'm going to choose the top equation. So 5x minus 5 times 2 equals 0. Negative 5 times 2 is negative 10. Add 10 to both sides, which gives you 5x equals 10. Divide both sides by 5 to get x equals 2. And y was also 2. I forgot to put that there. Okay. Number 7, I'm going to add these equations together. 6x plus negative, notice you can put a 1 there, 1x, so that gives you a 5x. Your y's cancel, equals 10. Divide both sides by 5 to get x equals 2. Now, I'm going to plug that 2 into either one of my equations. I'm going to choose the top equation because everything's positive up there, and so it makes me happy. So 6x plus y equals 16. I'm going to plug in a 2 for my x. 6 times 2 is 12. And then I subtract 12 from both sides to get y equals 4. Okay. Now let's look at number 8. So 4x plus negative 4x are going to cancel. Negative 1y plus 3y is 2y. And then 7 plus 3 is 10. Divide both sides by 2 to get y equals 5. Now I'm going to plug that into one of my equations. I'm going to choose the top one. So I've got 4x minus 5 equals 7. So I can add 5 to both sides, which gives me 4x equals 12. Divide both sides by 4 to get x equals 3. So my x was 3 and my y was 5. Problem number 9. We are going to combine these two equations. This one's a little tricky. You've got 2x plus negative 3x, which gives you negative 1x. Those y's are going to cancel, equals 0. Divide both sides by negative 1 because you still have to get that x by itself to get x equals 0. Now I'm going to plug 0 into either one of my equations. I'm going to choose the bottom one this time. So I've got negative 3 times 0 plus y equals negative 5. Negative 3 times 0 is 0. 0 plus y is just going to give us y, and that equals negative 5. Notice how in all of these problems you are getting whole numbers, meaning no fractions or decimals. I did that on purpose since this is just supposed to be a very basic overview. So when you do your homework assignment on this, you are just supposed to get beautiful whole numbers. They should not be anything extravagant. All right, so number 10, negative 5x plus 6y gives us x. Those y's cancel. 13 minus 15 is going to give us a negative 2. Now we plug that negative 2 into somewhere into our equations. I'm going to choose the top equation. So x equals negative 2, so I'm going to plug the negative 2 into my x value. Negative 5 times negative 2 is a positive 10. Subtract 10 from both sides to get y equals a positive 3. So that is the last problem we are going to do regarding the addition or elimination method. So now let's move on to the substitution method. Okay, in this method we are going to be substituting, as the name would indicate. In these next 5 problems, 11 through 15, we are going to have either y equals a number or x equals a number, or and x equals, this and this. So what we do is we take what our x equals or our y equals in this case, and we're going to box it. And we're going to draw an arrow to the y of the other equation. That is where we are going to plug in that negative 3x plus 10 into the other equation. So I have negative 4x plus 2. And instead of writing my y, I'm going to open my parentheses and put negative 3x plus 10. Okay, so then I distribute my 2 because I'm trying to solve for those x's. So I get negative 4x. 2 times negative 3x is negative 6x. 2 times 10 is 20 equals negative 10. Then I combine these like terms to get negative 10x. Bring down your 20. Then I'm going to subtract 20 from both sides to get negative 10x equals negative 30. Divide both sides by negative 10 to get x equals a positive 3. Now we plug our answer back into one of our original equations. I will tell you the equation where we boxed is going to be the easiest one to use. And that's going to always be the case in the substitution method. So we have y equals negative 3x plus 10. So I'm going to plug in my positive 3 in for my x. So negative 3 times 3 is negative 9. Bring down your 10. Negative 9 plus 10 is a positive 1. So that 3, 1 is our answer over here. Number 12. So I'm going to take this 3x plus 9, because that's what y equals. And I'm going to draw my arrow to the y of the other equation. So I have negative 4x minus 4 times 3x plus 9 equals negative 4. So now I need to solve for x, so I'm going to distribute that negative 4 into those sets of parentheses. So I have negative 4x minus 12x minus 36 equals negative 4. Combine your like terms to get negative 16x minus 36 equals negative 4. Add 36 to get negative 16x equals a 32. and then divide by negative 16 to get x equals a negative 2. So now I'm going to plug that negative 2 into either equation, but as we learned in number 11, it's the easier equation would be the one that we boxed. So I'm going to plug in my negative 2 in for my x. 3 times negative 2 is negative 6. And negative 6 plus 9 is a positive 3. Okay. So now let's look at problem number 13. I'm going to plug in my x plus 3 into my y of the other equation. So I have negative x plus 3, and then instead of writing the y, I'm going to write x plus 3 equals 1. I'm going to distribute that 3 to get negative x plus 3x plus 9 equals 1. Negative x plus 3x, I'm combining my like terms. That gives me 2x. Subtract 9 from each side to get 2x equals negative 8. Divide both sides by 2 to get x equals negative 4. Okay, now I'm going to plug my negative 4 into my boxed equation. So instead of writing x, I'm going to put a negative 4. And you get y equals negative 1. Number 14. I've got negative 3x plus 7, and I'm going to plug it into the y value of the other equation. So I get 2x plus 2, and instead of writing the y, because it's y equals, I'm going to write negative 3x plus 7. Now I distribute my 2 to get 2x, and then 2 times negative 3x is negative 6x, and then that's a plus 14 equals 6. Combine your like terms to get 2x plus negative 6x is negative 4x. Subtract 14 from both sides to get negative 4x equals negative 8. Divide both sides by negative 4 to get x equals a positive 2. And now I'm going to plug in my 2 for my x into the boxed equation. Instead of writing x, I'm going to write a 2. If you can't read that, I apologize. It says y equals negative 3 times 2 plus 7. So negative 3 times 2 is negative 6. Negative 6 plus 7 is 1. Now I'm going to have my 4x plus 12. And I'm going to plug that into the y of the other equation because it was y equals. So I get 2x minus, and instead of putting the y, I'm going to put my 4x plus 12. And I'm going to distribute this negative 1 into both terms in my set of parentheses. So I get 2x minus 4x minus 12 equals negative 8. Combine your like terms to get negative 2x minus 12 equals negative 8. Add 12 to both sides to get negative 2x equals 4. Divide both sides by negative 2 to get x equals negative 2. Okay, so I'm going to plug that negative 2 into the x of my top equation, the one that's boxed. So I'm going to plug that negative 2 in for that x. Four times negative 2 is negative 8. And then negative 8 plus 12 is a positive 4. That's our answer. Now the very last 5 problems that we're about to do are going to be the absolute trickiest, because we are supposed to use the substitution method for these problems, but in the substitution method you are going to have it equal to some variable, either y equals or x equals. So what we actually have to do is get that y or x by itself. We have to do that step for ourselves in this. They don't do it for us this time. So what I have to do is find the positive variable with a coefficient, meaning the number in front of the variable, of 1. So I have to have either an x by itself or a y by itself. Well, let's look at number 16. Can't use this x because it's negative. We want it positive. Same thing with this y. It's not positive. This one is positive and has a coefficient of 1. So this is the one we're going to use. So we have to get that variable by itself. So to get it by itself, we would add 3y to both sides. So our new equation is going to be x equals, when you add 3y to both sides, that becomes a positive 3y, and then you have your negative 9. So now what we do is we take that 3y minus 9, and since it was x equals, I'm going to plug that into the x value of my other equation. So I have negative, and instead of putting x, I'm going to put 3y minus 9. Bring down your minus y and your negative 7. So we have to distribute that negative 1 into both terms in that set of parentheses. Oops. Trying to help this look like it's getting a little hard to read. So negative 1 times 3y is negative 3y. Negative 1 times negative 9 is a positive 9. Bring everything else down. So negative 3y minus 1y is negative 4y. Bring down your 9 and your negative 7. Subtract 9 from both sides to get negative 4y equals negative 16. And you divide both sides by 4 to get y equals a positive 4. Okay, so in the last 5 problems, we always would plug this in to the original, or to the boxed equation, but we have to do from the original equation. Just in case we made a mistake, we want to do it from the original equation. So you can choose either one of those equations. I'll just stick with the bottom one. So we've got x minus 3y equals negative 9, and y was 4. So I'm going to plug that 4 in for that y. So x minus 12 equals negative 9. Add 12 to both sides to get x equals 3. So we solved by the substitution method, but we had to get a variable by itself first. So let's look at number 17. We're looking for the variable that's positive and has a coefficient of 1. It's kind of easy to spot out on this one because all of these have coefficients that are higher than 1. So our new equation here is going to be x equals. So to get this negative 4y on the other side, we would have a positive 4y and then plus 7. So I'm going to plug that 4y plus 7 into the x of my other equation. So I'm going to have 2 instead of writing x, I'm going to write 4y plus 7. Bring down your plus 3y and your negative 8. Now I'm going to distribute that 2 to get 8y plus 14 plus 3y equals negative 8. So I have 11y from combining my like terms plus 14 equals negative 8. Now I subtract 14 from both sides to get 11y equals negative 22. Divide both sides by 11 to get y equals negative 2. So now I'm going to plug it into either equation. Again, I'm just going to stick with the original equation I started with, which is x minus 4y equals 7. So instead of writing y, I'm going to write negative 2. Negative 4 times negative 2 is a positive 8. Then you subtract 8 from both sides to get x equals negative 1. Moving on to problem number 18. We're going to add these two equations together. Oh wait, no, I'm thinking of the addition method. I'm sorry, guys. Let's try that one more time. So we need to get the y by itself, because this is my only variable that is positive and has a coefficient of 1. So to get that y by itself, we would have to add x to both sides. So that would make that a positive x, and then you have minus 3. So I'm going to plug in this x minus 3 into the y of the other equation. So I have negative 3x minus 3, and instead of writing y, I'm going to write x minus 3. Distribute your negative 3 into the both terms inside of that set of parentheses to get negative 3x minus 3x plus 9 equals negative 9. Combine your like terms to get negative 6x plus 9 equals negative 9. You're going to subtract 9 from both sides to get negative 6x equals a negative 18. Divide both sides by negative 6 to get x equals positive 3. Now I'm going to plug in that positive 3 into my original equation, which was negative x plus y equals negative 3. So I've got negative 3 plus y equals negative 3. Well, if I add 3 to both sides, you would get y equals 0. Now let's move on to problem number 19. So my variable that is positive and by itself would be the x in the second equation. So to get that x by itself, to get x equals, you would have to subtract 3y from both sides. So that 3y would then be negative, and bring over your plus 7. So I'm going to plug in negative 3y plus 7 into the x of the other equation. So I have negative, open parentheses, negative 3y plus 7 minus 2y equals negative 6. And I'm going to distribute that negative 1 to get rid of the coefficient in front of those parentheses. Negative 1 times negative 3y is a positive 3y. Negative 1 times 7 is negative 7. Bring down your negative 2y and your negative 6. So combine your like terms. 3y minus 2y is y. Bring down your negative 7. Add 7 to both sides to get y equals 1. Now I'm going to plug this into my original equation, which was x plus 3y equals 7. And instead of writing my y, I'm going to write my positive 1. So 3 times 1 is 3. Subtract 3 from both sides to get x equals 4. Now to the final problem of this lesson. Oh, see, I almost did it again. So we want to get this x by itself because it is positive and has a coefficient of a positive 1. So I want to get x equals. To do that, I need to add 2y to both sides, which would give me a positive 2y, and I bring over that positive 1. So I'm going to plug in 2y plus 1 into the x of the other equation. So it's negative 3 times 2y plus 1 plus 4y equals negative 5. So I distribute that negative 3 into both terms in that set of parentheses. So I get negative 6y minus 3 plus 4y equals negative 5. So that gives me negative 2y, because I combined these like terms, minus 3 equals negative 5. Now add 3 to both sides to get negative 2y equals negative 2. Divide both sides by negative 2 to get y equals positive 1. So now I'm going to plug that 1 into the y of my original equation. My original equation was x minus 2y equals 1. So my y was a positive 1. So I'm going to plug that into there. Negative 2 times 1 is negative 2. Add 2 to both sides to get x equals 3. I hope this video has helped you. Remember when you were working on your homework for this section, remember all of your answers should be whole numbers, meaning if you get a fraction or a decimal for any of these problems, you did something wrong. Please do not hesitate to ask for assistance on this. I wish you the best of luck.